On this episode of Scotty's Garage, we're up to part 4 of our CNC Plasma Table build, and it's time to do the electronics. Welcome back to Scotty's Garage, where we're building this CNC Plasma Table build using plans that we got off the internet, specifically from JD's Garage. Now, those guys have come up with this very cool mini CNC Plasma Table build, and I liked the idea so much I thought, let's build one for my own workshop. And so far it's been going really well. So week 1 was building the frame. Week 2 was doing this X and Y axis business with all the 3D printed parts. And then week 3 was mounting all the motors and the belts and the belt mounts and that sort of thing. So we have our little stepper motors fitted up. We've got all our belts, our drive belts, and our mounts all fitted up. It moves. You know, I mean, it's a little bit tight at the moment because it's trying to pull a motor and a belt. But yeah, everything moves on its rollers quite well. At some point, I will have to strip off these bars, strip all the paint off these bars because the paint is starting to rub off onto the rollers. So we will have to clean that up before we get right into the actual working plasma table business. But this thing is coming along really nicely. Now, of course, being a CNC controlled project, you know, there's computers involved, and so we're going to be building our control unit using the plans. This is something I've never done before. I mean, I've done plenty of electronic stuff before. In a previous life, I was a telecommunications technician, so electronics and all that, it doesn't really scare me, and the wiring doesn't scare me, but this is still well above what I've ever done before. I've never wired up stepper motors, but I've done similar sort of stuff, so I don't think it's going to be too scary. The plans look pretty accurate in what we need to do. So we're going to mount a box. This large box we see over here, and you saw in the intro, it's going to be mounted under the frame here, and all the wiring is going to run up to the motors and to limiter switches and all sorts of stuff. So let's get into it and have a look at what's involved. Now, I know a lot of you would love to do a CNC Plasma Table build, and as I've shown, up to this point, it's all pretty much nuts and bolts stuff and relatively easy. And this is going to be the part that scares people, building the electronics. Now, we're starting with this metal box. Now, the original JD Garage build, they used a plastic box, and I've been steered away from doing the plastic box thing because a few people have reached out to me and said, do not do a plastic box. You still get a lot of EMF, so electromagnetic interference, and or EMI, whatever you want to call it, but you get interference, and they reckon use a metal box, and that will be the way to go. So I bought this box through Vivor. There's the label right there on the side. So I got it through Vivor. I paid for it. It showed up literally, I think I ordered it one day and it showed up the next day. So service was amazing. Has a little key thing to open the door. I do have a couple things sitting inside here. I'll just grab them out. I don't need that. And that and that. And that's what it looks like inside. It has a back plane there that we can unbolt, and we will unbolt so we can arrange. I've already sort of sat things in there to check that the height works. So the biggest item we have to go in here is a power supply. Let me just grab that out. So this is the largest single item you will have to put in this. So this is a 24 volt power supply, and I'll just show you that it fits. So regardless of whether we build this in or out of the box, we know this fits because we've already sat it in there. So that is the largest item that needs to go in there. So what we'll do is we'll unbolt this back plane, bring it out here on the table, and start arranging all our components that need to go on there, and then we'll be able to transfer it back into the box. But basically, if we keep everything within the bounds of these 4 nuts, we should have no trouble, all right? the boxes can be kind of, I can't remember what this one cost. I think it ended up costing me just under $100, I think. But they can be quite pricey. So shop around, see what you can find. But looking on Amazon, I couldn't find anything of a decent price and the right size. You got to make sure you get something that's big enough. Sure, I could have gone, with a smaller box, possibly. But, you don't want to get a box that's too small and find out nothing fits. And no, that's not an euphemism or for anything. That's just like the way it is. Having too small a box is going to be problematic. So let's go with a slightly bigger box and we know everything fits. And yeah, if you want to read more into that, then that's up to you. Alrighty, let's pull our nuts out of our big box. So there's our back plane. I've just put a small T at the top there, just to indicate that that is going to be the top of our installation, I guess. Now we can move our box out of the way. Where's that key? So this is what we're working with. We've got a 24-volt power supply. What else is in here? Just grab bits and pieces. All right, so okay, we don't need them just yet. They're junction blocks and various things. Limiter switches. All right, we'll stick them back in this bag for the moment. We'll get to them later. As you can see, a lot of stuff came from Amazon. Amazon's not cheap, but you can get everything. So I guess that's my recommendation there, is that when you're looking for very specific things like a 24 volts power supply that, 20 amp, 24 volt, that does 110 and 240, obviously we've switched it to, well, actually 220, but we've switched it to 220. Easy to find. Same with all the controller units and all that sort of stuff. We have some switches. So one of these will serve as our power switch for the unit. A lot of the stuff you'll find too when you order through Amazon that you can't just buy one. So you'll buy there's a packet of 5 of these switches. So I'll have some extras for things down the track. But yeah, big red switch. Okay. Besides the 24 volt power supply, there's also a 5 volt power supply. So that's apparently the guys had to introduce that because they were getting interference from running everything off the one power supply. So there's some items that they had to add which had to run off 5 volts, and therefore they divided it. And that's why they have a 5 volt power supply as well. Basically, we'll run our power cord in to our 24 volt and then loop it across to the 5 volt, and then they will power everything else in the box. Right, we've got a few other things here. I'll get to that in a sec, but as I said last week, with the stepper motors, you require a driver for each stepper motor because we have a motor for the y-axis, we have a motor for the x-axis. There's 2 controllers that you need. We're going to use, obviously, that motor for the Z-axis. So there's another motor that we'll need. And then they have an accessory called a tube notcher that I am also going to build, but we'll do the plasma table first, and then we'll get into the tube cutter, and we'll build that as well. But it means that while I don't have it with me, I have 3 stepper motor drivers here, but I've got another one coming. So I have to know that I've got enough space in this box for my 4th driver. So I believe the smaller motors all use the 6600s, and I believe that's what that is. So I have 2 of them at the moment. and I've already configured their little dip switches on the side as per the instructions on JD's garage. I'll have to look up which one was which again, but basically one's going to be for the x-axis, one's going to be for the z-axis, and then another one of the same size is going to be for the tube notcher thing. And then we've got this larger driver for the larger motor, and I believe this is the DM, yeah, there it is on the side, DM556. So that is for the larger motor. That's going to be the y-axis. I always have trouble with that. So yeah, the larger controller goes for the larger motor. So basically we're going to position, I guess, them all in a row, try and keep it simple. They all sort of sit on their end. They've all got heat sinks built into them as well. So I'm not sure how much heat this is going to have in it, and whether we do need to think about that down the track. But basically, yeah, let's work out our positioning. Now, obviously, the JD Garage guys have sort of a serving suggestion in terms of placement. I disagree with some of the placement on some of their stuff, mainly with they've got a lot of their controller wires going straight in through the top of the box. I don't like that idea because, I mean, this has a water pan on it, and if you've ever seen a plasma table in action, they can, if your water level's too high, you can get a bit of splash happening. And I think having wiring going through the top of the box is just looking for problems, just asking for problems. So, you end up with some splash going onto the top of the box, and then all of a sudden you've got water in with your electronics, and it's all bad. So we'll go in through the side for that reason. So I'm going to move things around to suit that. Now, I believe this is called an opto isolator, and I think this is why the 5 volt has been introduced into this. Let me just slide that out. I'll just be very careful with it. I don't want to drop it and damage it, but also don't want to, we've got our anti-static bag. That's what, if you're not familiar, these bags are anti-static bags, so you can't zap your electronics. So I believe this opto isolator is in there to basically help reduce interference with the motors and that sort of thing. So we've got to wire that between our 5 volt to our drivers, basically. So I believe that's how it works. So, and of course, with all these things having, like this particular unit, obviously you see the back plane is all exposed contacts. We're not going to be able to set that directly down on metal because it'll short the shit out of it. So you don't do that. So what we're going to have to do is basically design and 3D print something that mounts, that sort of stands this off that metal, supports it, and allows it to attach to it. So we're going to have to come up with a 3D printed design of our own making, I guess, to kind of stand it off that metal plate. So that's something that's going to add. I don't think this is going to be all done today, put it that way, because obviously we have to design and print. It all takes time. Thankfully, all these electronics have little screw connections for the wiring. So basically, it's all going to be a bit of a screwdriver job with some exposed wirings poking in and tighten down. There's no specific connectors for this sort of stuff, so that makes it a little bit easier. Right, so there's our isolator. Don't know what that was. All right, got a couple 5 volt relays can't remember what they're for, but it's the same deal. They've got exposed connectors on the, or connections on the back of the printed circuit boards. So we're going to have to make little standoffs for those. I'll unbag them when it's time, but yeah, just basically there's a little 5-volt relay in each of those. I'm not 100% sure what purpose they served, like what they're a relay for, but we'll look at the instructions and I'll let you know. And then there's the brains of the unit. So they used to use something called an Arduino, which is the Arduinos, and they're still around. People use them all the time to control all sorts of mechanical, electronic things, you know. So if you want to activate this and this motor and do this, and people use Arduinos for a lot of that sort of stuff. Now, the guys found that the capabilities of those probably weren't as great as they wanted, especially for something like this. So they went to this, which is a ESP32, and this is basically that's the chip, and it's got a little USB plug-in that go into, or like a mini USB plug that plugs into, like a USB 3 connection, I should say. Or USB-C, is it USB-C? USB-C connection. So little USB-C connector on that, and that's the processor and that's the computer for the whole job. So tiny little thing, it plugs into this, and then this, you know, because you can't, like, you know, you've either got to have something that you can plug this into, or you've got to solder your wires directly to it. No one wants to be soldering wires to a computer chip. So basically this plugs into this board, and then this board has all the breakouts for basically, as I said, little screw connectors. So poke your wire in, tighten it up with a screwdriver. So that's how that works. So let's not drop these things. Luckily I have spares because I'm an idiot, and when I pushed buy on Amazon, it had 3 selected. It was like instead of like just buying one pair, as in, say you need the computer, the chip, and then you need your little breakout thingy. So you need them as a pair. And in the thing, I didn't notice that it was showing 3 sets. Well, I got 3 sets, so I have backups. I am going to do an emergency stop switch on top of the box. It's going to be the only thing that's on top of the box, basically. So, yeah. So it's going to be our emergency stop switch. So basically, if something goes wrong, bang, stop it. So that'll be the only thing that goes on top of the box. What else was there? I think there's some... trying to think if there was anything else. Maybe there isn't. No, I think that's just about everything. So when you think about it, there's actually not a lot there. I mean, yes, I've got to find positions for all these things, but overall, you know, you basically got a couple power supplies, a processor, this isolator unit, which again, I'm not 100%, I'll have to look up what it is actually fully for, but basically I know it's got to be wired between some of this stuff, and I need to go and read all the instructions thoroughly again to work out what all that is. I've had a bit of a browse, I've had a couple browsers through, but sometimes you've got to read these things a few times for it to really stick. So relays, controllers, isolators, drivers, some power supplies, and just basically we've got to find home for all this stuff in the real estate that we have, which is our plate. Right, so before we get started with our positioning, we need to create our standoffs for all our circuit boards. So I'm going to do these in 3CAD and 3D print them basically. So I've already started. I've already done the one for the optic controller just to prove that I could do it. And now I'll show you the process that I went through so I can create it for these next pieces. So this one's one of the 5-volt relays. So there it is out of the packet. Same sort of deal as all the others, you know, so exposed contacts on the bottom and basically in one end and out the other is the way it's designed to be. So what I'm going to do, I'll make all the standoffs kind of the same in that I'll make them 4mm thick and I'll have 4mm holes holding the standoff down to the plate. And then all these holes in the circuit boards tend to be 3mm from what I've seen. So I will make basically little stanchions, pylons, whatever, for them to stand up and be able to screw them down too, you know. So that is my plan. Anyway, 5-volt relay. So, right, so the best way I've worked out to do this is to make our standoff longer than the actual board itself, because all these holes in our printed circuit boards are really close to the end. And so if I made a 3D printed, like a 3D printed thing that emulated that, the wall thickness would be really thin. So I'm going to make them slightly bigger so I can make the actual standoff part thicker and therefore less likely to break when I screw something into it. So that is 26mm wide, 50mm long. So let's go for, I think if I go 30 wide, I'll just say 50 long. Go 30 by 55. Let's go with that and see how that looks. All right, so I've got some FreeCAD open in front of me. I'll show you how this all works. So I'll position it. I want to draw a rectangle. It's pretty simple. All right, 0, 0. And then we'll go out to, what did I say, 55 by 30. All right, so because of the positioning of the holes on this circuit board, I'm not going to attach the standoff through in the corners like I did with my other one. Here's the other one if you want to see. So that's what I've created for the other one. If I rotate it around, say I go top down, you'll see that the ends are symmetrical, and then in the middle there was 4 holes kind of in symmetry, and I didn't think we needed to use all 4 holes. So what I've done is I've offset the holes on either side to use them. And I mean, if 6 3mm screws can't hold the thing down, then we've got problems. So I'm sure it'll be fine. Anyway, moving on to our one for our 5-volt relay. So what I'll do is I'll go straight in through the center on this one, and I'll just have 2 screws, one at either end to hold it down, and then there'll be 4 screws on the outside. So we'll start with our base first. All right. So I want hole, circle by center. What did I say? 5, 15, 4mm hole. Boom. 50 and 15, 4mm hole, and that's what we'll use to attach the base. All right, so that's our base part of it, and I'll close that up. I'll pad it out. I'll make it 4mm thick. Boom. And there's the base. Okay. So now we need the next part. So we're in our pad, create a sketch, and we want another circle. So now we're going to go to our outside portions. Now I've made it longer than it needs to be, remember? So now I need to work out our hole separation. The only problem with using these calipers is they do not lock in place. So let me stick my thumb on there so I can hold it in place. So the plastic calipers are great for just this general sort of stuff, except when you want to lock it in position. So it looks like center to center, it looks like 44 mil. And then on the other side, so just remember 44. And that's the other way, and that's 20. So 44 and 20. So that's kind of our rectangle for those. Now, of course, I made it an uneven number. So I made it 55 long, but I need the holes to be 44 apart. So, and 20 apart. So what did I say? It was 30 wide. So obviously 30 minus 20 is 10, divided by 2 is 5. So again, I'm going 5 mil up from our corner. So 5 up. And if I want to make it kind of even, what I say is 44, 55 and 44. 11 divided by 2 is 5.5. So I'm going to have to go 5.5. And now I want to make it 6 mil. All right, so same again, 5.5, but this time it's going to be, I guess it's the same 5 mil from the edge, so it'll be 25. So 5.5, 25, boom, 6 mil. All right, now I'll repeat that at the same end. There probably is a way of, if I had this centered, sorry, I'm pointing at it instead of using the cursor. If I had this centered across the plane, I could do a mirror function, but I don't like to do it that way, so I'll just do it this way. So again, so 5.5 off the end, so it makes 49.5, 5 mil up. How about we zoom in a little bit? So 5 mil, 49, whoops. 6. And same again, 49.5 and 25. 6 mil. Boom. All right. So they're going to be our stanchions. So our supports. So now I've got my holes. So the distance from there to there should be 44 mil. So let's just do a quick. So what do we got there? 49.5 is our center. It's 5.5 to that center. So 49.5 minus 5.5 is 44 mil. So it should be correct. All right. Now I need to have, so I've got supports are going to be 6 mil in diameter, but I need 3 mil holes through the middle of them. So again, we want center by circle. Now I've already found the centers. I just rest over it. It gives me the X. Click that, 3 mil. Boom. Same again. X, 3 mil. Give me my X. There it is. 3 mil. And X. Whoops. 3 mil. Boom. Okay. So we got to that point. Close that. You can see our holes are marked on there. So now we go pad, 10 mil, boom. Simple as that. So our stanchion is going to be 10 mil off the top of that. Is that too high? I don't know. I don't care. As long as it's high enough that these contacts can't touch underneath. And remember, we're going to have some screws under there as well. So it's a good idea that they'll not be able to touch the heads of the screws under there as well. But that little 5-volt relay should sit on that and it should be perfect. Should be. So I'll need to make print two of those. All right, so let's save. All right, so select it and we'll output it. So export as an STL mesh plasma table. So I'm just going to call that 5-volt relay standoff. And I'll make two of them.
A few moments later.
So here we are, 25 minutes later with our first standoff. So there's the product. Okay, so we've designed that in FreeCAD, printed it out on the 3D printer, which you can hear humming away in the background. And there it is with the 5-volt relay mounted. Now I've got the screws on the bottom just to show you that there's plenty of clearance between the mounting screws and the back of the PCB. But yeah, so got that. And then we've got the relay mounted. So we've just got 3mm screws holding it in, 4mm screws will be holding it onto the back plane. But yeah, and I mean, this is the beauty of 3D printing. And well, to be honest, what will be the beauty of the plasma table? That I can take an idea and create something and make it reality within minutes. I mean, yes, it took 25 minutes to print on the printer, but that's fine. It took, 5 minutes to design on the program, slice it, clone it, so we could print both of them at once. And then, boom. I've had an idea. I've created an item, in the computer, and then created it physically with the machine. And that's just amazing to me. Like, it's fantastic. So now we can use these to attach our 5-volt relays onto our backplane. Of course, we're going to do the same thing with all the other PCBs as well, printed circuit boards, if you're not familiar with the vernacular. But yeah, I think that's pretty cool. I'm really happy with that. So as I said, the machine's printing out one of the bigger ones right now. And yeah, once we've got all that, we'll be right to go. But not today. So it is 2 weeks later. Yep, I've been away for my grandmother's 100th birthday. So that was, last weekend. And then I've been away all week doing drag challenge things. So yeah, it's been a lot going on. But I've been in the shed all yesterday, or most of yesterday, and all of today. Today I've got Bathurst playing on the TV up there on the big screen. Yep. Oh, look, someone's just gone in the sand trap. Right, well, the rain started to come in at Bathurst, then we're starting to see some action. This is the third safety car that I think they've had in the last 5 minutes or 10 minutes. Anyway, while that's playing over there, I've been working away on my controller unit for the plasma table. So here's the back plane and here's everything fitted to it. I know we've jumped forward a bit, mainly because, well, I left the tripod in my Falcon, and the Falcon is at Ford Australia right now. So anyway, it's a different story. I've got a Ranger that I borrowed for a week or two. Anyway, so I've got all my components mounted to the backplane. 24-volt power supply, 5-volt power supply. I've got these couple breakout, so there's going to be an earth bar, and that's going to be a power bar for 5-volt. Controller chip's going to be fitted there. Obviously, I haven't fitted it just yet because there's no need to until we do the wiring. There's our opto isolator, that's to balance out the signals for the limiter switches and stuff like that. And then we've got some 5-volt relays as well for like torch control and stuff like that. And then we've got our stepper driver controllers, our controller modules for the stepper motors. So yeah, there's a lot here to wire up. 123 wires, I believe, by the plans. So yeah, so the big one here is going to be for the y-axis. That's the big mount that goes along the main bar, and then we've got x-axis there, and then the z-axis is the up and down for the torch height and all that sort of thing. So yeah, we've got it all mounted to our plane. Now it says in the instructions, leave the wiring until you put it back in the box. I'm like, that doesn't make sense to me, because it's much easier to do all the wiring here outside the box, I think. I mean, you only need the wiring that's going outside the box to be done later, I guess. All the internal stuff I think we do now, and then we fit it into the power box. And from there we can work out what we need. But everything is attached to the back plane. Obviously, got some screws poking through, but this sits off the back of the box, so I don't think that's going to be a problem. Yeah, I've made all my standouts for my various printed circuit boards, so designed and 3D printed them. That was pretty easy. So yeah, now it's a matter of wiring it all. So basically we're going to have a 240 volt cord that comes in, connects to the 24 volt power supply there. We're going to jump that across to the 5 volt power supply as well. And then everything else gets run off these power supplies. Obviously, if you're dealing with 240 volt, you need to be careful. All right. I have a sort of a unterminated cord here from J-Car that I'm going to use to power that up. It's 3 wires. It's pretty simple, but I'm not going to tell you how to do it. You need to look it up yourself, because I don't want to tell you how to do it and then have you screw it up and electrocute yourself. So if you're not confident how to do it, don't do it. And yeah, you need to do your own research on that regard. I'm just covering myself that way. I have left a space here on my back plane for another stepper driver to be installed later. So that's going to be for a tube notcher. That is an accessory for this, but you know, we don't need it just yet. I just wanted to get the unit running first. But I have left and pre-drilled some holes there to fit one of these little stepper driver things. So anyway, I think there's enough talking about it. I need to get in and start doing some wiring. So I've got some shielded 2-core here. I have some shielded 4-core. Oh, yeah, 4-core plus a shield. The shielded wires are to stop electromagnetic interference. We may have mentioned that pre all this, but yeah. So I've got my wires, and then I've got a bunch of just normal sort of automotive wire in various colors to run some of the other stuff. So all this internal stuff will just be like just wires run to various places. And there is a list. As part of the plans, there is a list. And as I said, there's 123 connections you have to do. So rather than show you all how that goes, I'm going to go through and do it, make it all nice and tidy as I can, and then I'll show you what the result is afterwards. But basically it's going to be stripping, you know, a few mil off the end of a wire, poking it in an area, and then using a screwdriver to do it up. I mean, it is that simple. All right. There's a couple pieces here where I'll probably put one of these little connectors on it, so especially for these power supplies and for the bars down here. But for most of this stuff, it's just going to be like 3 to 4 mil of wire poked in and screwed down on a screw terminal. And basically as simple as that. Yeah. So let's make it happen. Check back with me in a little while.
A few moments later.
Right, so here we are several hours later. I mean, Bathurst is over. It's been over for over an hour. So yeah, I've been here all afternoon crimping and terminating and wiring. I haven't got it all cable tied together yet, but that's kind of the basics of it. Trying to keep it as neat as possible, but you know, it's hard to do. So, I haven't terminated these ends yet. These are the ends that are going out of the case to the motors. There's an extra one there, so I've got 3 for the motors and 1 for the motor that's going to run the tube notcher. So I thought I'd wire that in while I've got the chance. Yeah, I've got most of it there. I think I've got 70% of it done. I've still got to do some of the wiring for the limiter switches. So the limiter switch wiring has not been done yet. So maybe we're not at 70%, but high 60s. So limiter switch wiring. The drivers are all wired. The relays are 80% done. The controller is, I think, probably 80 or 90% done. Opto isolator is the one that has all the limiter switch wiring. So yeah, it's still got a bit to do. Same with the earth and 5-volt buses down the bottom here. Power supplies are all wired up. So yeah, we are most of the way there. But unfortunately, it's not going to be all done in this episode because it is now Sunday night. I mean, I have still been in playing catch-up mode, so this will probably hit the net Tuesday by the time I get around to editing. Yes, Grandma's party has put me behind, but it's one of those things you got to do, you know. Grandma only turns 100 once, and she is my last living grandparent. So, yeah, the older I get, the less relatives I have. And this year has been a big year in that regard, in that I've lost 3 aunts and uncles already this year. So, yeah, it hasn't been great. Anyway, so, yeah, I've got most of the wiring done. So I think next episode we need to terminate these, terminate the limiter switches. We also got to fit the limiter switches to the actual unit itself, wire up the connections for the motors, and then program that little bad boy, plug him in there, or plug him in there and then program him, whichever way we go. And then, yeah, it may work. But you'll have to see all that on a future episode of Scotty's Garage.